To other Chapter 10 problems. Here is a generic one. It's a little bit harder than the ones we've been doing. So we have this circuit here. They have already converted everything to impedances for us, saved us a little bit of time. And it's our job to figure out the V0 here. Now with that said, we have to decide between all of our different methods what would be the best to solve it. First off, source transformation doesn't look super helpful right here. We don't really have any sources in good positions, and if you transform them, it becomes even in better positions. So we probably won't do that. Thevenin, I would not do Thevenin at all because we've got the dependent source there, and as we know, that makes our life much more difficult. We could do node voltage, but there are quite a few nodes here. I think that would be harder than we'd like. So I think the best choice here is going to be mesh current. Now you say we still have 4 meshes, but we're actually going to know what 2 of them are already. So if I call this I1, I2, I3, I4, we know right away that I2 is negative 4 angle 0. And we know that I3 is 2Ix. We can also do our dependent source equation. Ix is equal to I4 minus I3. And now we need to write out 2 actual equations here. So for the first loop, I'd have negative j times I1 plus 12 angle 0 plus 1 times I1 minus I3 equal to 0. And then for the fourth loop, I would have ji4 plus 1 I4 minus I2 plus 1 I4 equal to 0. And do remember that we know what I2 is. I2 is negative 4. And so that means, looking at just this equation right here, I'm going to be able to solve for I4. So let me actually just, let's see here. I've got 1 plus j plus that. It's going to be 2 plus j I4. And then minus I2 is minus a negative. It's going to be plus 4 equal to 0. So then that means my I4 is going to be negative 4 over 2 plus j. Now I could go through and work out, say, okay, what is I1, what is I3? But it turns out we don't actually care, because in this circuit, what we're looking for is V0. And V0 is just 1 ohm times I4. So that's going to be negative 4 over 2 plus j. And we can go ahead and put that into our calculator to get our polar notation here. And let's see here. Complex polar. I'm going to get 1.79 angle 153.4 degrees. And so we can answer out V0 of t is 1.79 cosine omega t plus 153.4 degrees. Volts. Okay, so you see how by choosing the right method, this made this problem really not bad at all. But if we had chosen one of the other methods, we'd likely be here a lot longer trying to get the same answer. So it is really critical that you don't just have one method that you use for everything and ignore what you learned before. You need to be able to adjust and use the method that actually makes the most sense.